Today we're working on lesson 2-4, parallel and perpendicular lines. Don't forget to write your name, date, and period at the top of the paper. So we have here our objectives. Our first one is to create equations to represent lines that are parallel or perpendicular Oops. Let's see. To a given line. We will also graph the lines to show an understanding of the relationships between the slopes of parallel and perpendicular lines. We will also solve real-world problems with parallel and perpendicular lines. And our essential understanding is that the equation of lines can be used to help identify whether the lines are parallel or perpendicular. Parallel lines have the same slopes but different x or y intercepts. Perpendicular lines have the slopes that are opposite reciprocals. And here we also have our vocabulary in English and Spanish, and we also have our standards for this lesson. Our vocabulary is parallel lines, perpendicular lines, and reciprocal. Now we will write an equation of a line parallel to a given line. What is the equation of a line in slope-intercept form that passes through the point 89 and parallel to the graph of y equals to 3/4 x minus 2? Now, we know that if it is a parallel line, we need the same slope. And we need the same slope as this equation right here. So we will take that into our y equals mx plus b and copy down the same slope, which is m. And we will leave the y-intercept b blank. To find the y-intercept, we will need to find the point. We will need to use the point. So we will plug in 9 in y and 8 in x. And from there, we have to solve it out. So 9 equals to 8 times 3 is 24 divided by 4 plus b. And we'll just take that up here. And when we divide 24 by 4, that will be 6 plus b. The next step is to subtract 6 from both sides. And we have that cancel each other out. And now we're left with b equals to 3. So our y-intercept is 3. And now we will have our equation. Our equation, the same slope, 4x, 3 divided by 4x, and plus b, which is 3. And so here is the equation that is parallel. So these two lines means it is parallel to the line. So we will also understand the slopes of perpendicular lines. Perpendicular lines are lines that intersect to form right angles, 90 degrees. They are 90 degrees. The slopes of perpendicular lines are opposite reciprocals. So now We will also write an equation of a line perpendicular to a given line. So it reads here, what is the slope of the line that passes through the point, through the point 1, 7, and is perpendicular to the graph of y equals 1 over 4x plus 11. Now we remember that when we need it to be perpendicular, the slope has to be opposite reciprocals. And I will show you what will happen with that. So we need the slope from the given line, which is y equals 1 over 4x plus 11, and the slope was 1 over 4. When we take the opposite reciprocal of the rise over run, what we mean is that we will take the run, and that will end up on the top, and we will negate it so that it'll become a minus run, and then the rise will end up on the bottom of the fraction. Rise. So you'll switch and negate the top. And if we plug the numbers back in, we'll say minus 4, because that was our run, and we'll put in a minus in front of it. And our rise was 1, and that'll end up in the bottom. And we'll simplify that, and that'll end up as a whole number, which is minus 4. So this is our new slope. We say y equals minus 4x plus b. We still need to look for our y-intercept, the b, and we can do that by plugging in the point. We can plug in 7 for y and 1 for x plus b. Solve it out. Minus 4 times 1 is minus 4 plus b. The next step is to add 4 on both sides. These two cancel each other out, and 7 plus 4 is 11, and therefore our y-intercept is 11. And now we can just put everything together, have our slope minus 4x, and our b, which is 11. Now we ended up with this equation. This equation is perpendicular. This is the symbol for perpendicular. It's like an upside down T. This equation is perpendicular to the line. And now we will turn over to the next page. Classify lines. Identify whether the following graphs are parallel, perpendicular, or neither. Remember that if the lines are parallel, they have to have the same slopes. And if they're perpendicular, the slopes need to be opposite reciprocals. And if it's neither of those, it's neither. So here's our first problem. Y equals 2x plus 6, and y equals 1 over 2x plus 3. Now we notice for both of our slopes, they're not the same. And it might look like they're opposite reciprocals, but if we take the m on our first line, which is 2, and we'll just turn that into a fraction. If we put 2 over 1 through the opposite reciprocal process, which is minus run over rise, then we would have minus 1 over 2. And this is not the same. it does not equal to this slope right here for our second line, because the opposite reciprocal needs to be a negative 1 over 2 and not a positive 1 over 2. So they're not perpendicular. And they are not parallel. So it's neither. Okay. And now for number 2. We have y equals minus 5x and 25x plus 5y equals 1. To compare both of the slopes for each lines, we need to turn this into the points intercept, the slope-intercept form. Sorry. The slope-intercept form is y mx plus b. Y equals mx plus b. Now the first process could be to subtract 25x on both sides. So now we end up with 5y equals minus 25x plus 1. Then the next step is to isolate y, so we divide 5 in both sides. And now we end up with y equals to minus 5x plus 1. And now here we can finally see that in both lines we have the same slope. So we could say, since that they have the same slope, they are parallel. And there you go.